Hi, hello, good morning all of you. Yesterday's class we shared the thought of being positive. And I was very happy one of our student friends was asking about the ways to be positive. And my idea of being positive was, of course there may be number of ways, but I told him to be in a state of learning is one of the better ways to be positive. Yeah. In the state of learning, we always be very positive. It may be learning from our mistakes. It may be learnings by facing tough times. And no bar of time or no bar of place to learn. Let us keep learning. Being positive is what actually it will be a default. So to be positive is not something by our effort. So let us be positive by our deeds. Keep learning, keep learning. And one more thing, before I start my today's session, I would like to beg a pardon, because last session in the discussion of voltmeter, there was a small mistake that has crept. And I do tell a correction, please take a correction. In the case of increasing the range of voltmeter, we have given an expression. And in the final statement, I told if range of a voltmeter becomes n times the required series resistor G by n minus 1, I have told, I take a pardon. Please make it as G times n minus 1, right? Now today we will continue with solving of examples, models. Of course, we can have numerous models, and few among them today we will have a discussion on the definition of currents and also the concept of resistance of a conductor. And we follow with some more in the coming sessions. Now, look at this first example. Again, I am telling you definition of currents, concept of resistance and resistance of conductor. Right? Keep a notes with you, go through the concept, and now look at the solutions. The first example, I said, a conductor carries a current of 3 microampere. Simplest question is find rate of flow. Find rate of flow. Then it is simple definition. Yes, I is Q by T, and this is what is Q, NE, therefore N by T times E. Now I is given, N by T is asked. Now when you are writing N by T, N by T is nothing but I by E. Yeah, this is 3 microamperes. Therefore it is 3, 10 raised minus 6, multiples, submultiples. Generally, students do miss them in the examination. Do be very cautious about that. 3 into 10 raised minus 6 by of course 1.6 into 10 raised minus 19. I have told you 1 by E value 6.25 into 10 raised 18. So this is again 3. You have that multiplication. Please do it on your own. Now you got this N by T value. N by T value is 6.25. This is 3 and all multiples minus 19, and this one is, so it will be 10 raised 13. This will be the number. Right? Simplification, multiplication, divisions, please do it on your own. Now, let us see one more definition of current. Yesterday we have told 3 definitions for our examination purpose. Same current, but 3 types of definition. Let us take the case of second definition, which you remember, variable current. See this example. I said the charge through a conductor, the charge flowing through a conductor follows the equation, and the equation is given. Q 10t square minus 4t plus 7, again a submultiple 10 power minus 6 coulomb is also given. Now, t for time, the question is, simplest of the question would be find the current for t equal to 3 seconds, find the current for t equal to 5 seconds, 5.2 seconds, like that. That will be simplest question. but rather I am doing it a bit another model. How? My question is, find the charge that flows through the conductor at an instance of I is equal to 2 amperes. When the instantaneous current is 2 amperes, what is the quantity of charge that has flown? Complete charge, right? That is the meaning. Now again, let me take I, our definition, instantaneous current, because it is a variable current, right? You remember it is dq by dt, the derivative, which will give you as, this is 20t, yes, minus 4, 20t minus 4, 7 is a constant, derivative 0, and of course please do remember it is 10 rise minus 6. That is, I will write it as microampere. Now you see, for now he says I is equal to 2, therefore I am substituting T 2 ampere is equal to, 2 microampere I will say here. 2 microampere, 2 into 10 rise minus 6 is equal to 20t minus 4 into 10 rise minus 6, right? So substitute, what do you get? 20t is equal to 8, so t is equal to, yes, 20t, 6 by 20, t is 6 by 20, 3 by 10 seconds. Now I will substitute this value in Q, because it is asked the total charge that flows at the instance of this I is equal to 2 microamperes. Therefore now I will give the number as Q is equal to 10 into 3 by 10 minus 4 into 3 by 10 plus 7, and do remember all in microcoulomb. This is 10 power minus 6, right? Remember? So all this in microcoulomb, like this. So this is second definition that we have used, and I have shown a model. Supposing this question happens or appears to be simple, rather if you are asked to calculate, find current at t equal to 2 seconds or 3 seconds, then you write the expression for current and substitute the value of t. Otherwise, my example was bit additional information asking about the quantity of charge. Now, remember, yesterday we talked about the microscopic understanding of the resistance, which was the origin of resistance, why resistance arises in a conductor. Remember, lattice collisions, lattice vibrations, free electrons colliding with lattice, mean free path, relaxation time, drift velocity, remember current density. All the definitions and as well as expressions are yesterday I have discussed with you. Based on that, see, look at, I'm discussing one more example here. This time, a conductor is given, I'm giving in terms of a data. Supposing the question says, a conductor of length 75 centimeter, radius √3 millimeter, made of a material in which density of free electrons is 4 into 10 raised to 23 per centimeter cube, per centimeter cube, and if the conductor carries a current of 5 microampere, find the time required for an electron to move from one end to the other end of the conductor. This is the question that is formed. So remember, whenever you read the question, the most important thing is identifying the keywords I have told. Here it is asked with time, right? Finally, what is that we need? Time. So fundamental definition is time is equal to displacement by velocity, right? Time is. Displacement here refers to length. Velocity refers to, remember, drift velocity, because yesterday we have told, in the presence of applied electric field, all the electrons, free electrons, acquire only a small average velocity called drift velocity, but not acceleration. So this is what is L upon Vd, or V I write drift velocity, and how to calculate the drift velocity because length is already given. This time, this distance by velocity, V for the drift velocity. How to find drift velocity? You see, J is equal to NEV relation. J equal to NEV relation, I by A is equal to NEV. V is equal to I upon N A E. N for density of free electrons, A for cross section of the conductor, and E for charge of the electron. Therefore, if you substitute, what is that you get? T is equal to L upon, yes, this is I, denominator, it goes N A E. See, this is the final expression that you get. Now, the thing is that you have to substitute all of them in SI units. Look here, I have said this is centimeter. This is centimeter, this is millimeter, this is centimeter rise minus 3. So while substitution, let us use all SI units, and that's the key point. Next, one more thing is that unlike in the board examination, we did not do all the calculation. The ABCD options will definitely help you in finding the answer. How? Because here the order will be the important. How much is the order you get? So this L is 0.75, that is, I will write it as 3 by 4. N is given to be 4 into 10 rise, 23. It is per centimeter cube. If I convert that into meter cube, another 10 rise, 6 will add, because 1 meter is 10 rise, yes, minus 2 centimeter, right? And that is why this is 4 into 10 rise, 29, A value pi r square, r is given to be root 3, pi r square, this is 3 pi, again, it is millimeter, converted into meters, therefore it is milli, 10 rise minus 3 square, therefore it is minus 6, and E value 1.6 into 10 rise minus 19, and what is the given value of I here? This is 5 micro 10 rise minus 6. See, now the order will tell you everything. What is that? This is 29 and 6, 35 orders, and this is 25 orders, 35 minus 25, it is the order 10 we are getting. 10 rise, 10 we are getting. Apart from that, what is that? This is 4 cancel, this is 3, 9 pi, 1.6 by 5. So your expected order will be in 10 rise 9. So that is what is the case. So when you look at the options will definitely help you in finding the one. 10 rise 9 orders you will find, and that will be our answer. Don't ever go for complete calculation as you or use it in your board examinations, right? Because options will help you. So this is one example. And this example we have used a simple expression that current density J is equal to NEV. Look at one more expression here, one more example I am now doing. One more example. This example says a conducting wire of length 50 centimeter carrying a current of 3 milliamperes, and the cross section is 2 millimeters square, and also he says resistivity of the material is 1.8 into 10 rise minus 8 ohm meter. So this is a conducting wire with the length and cross section given, carrying current, and its characteristic resistivity are given. Now what is that is asked? Now for such current flowing through the conductor, find the electric field intensity inside the conductor which sets up this current. Find the value of E. Again, where to begin with is the very tough question the student generally gets. Now whenever a conductor is given, conductor current, which is the basis, our expression is V is equal to IR, you remember? V equal to IR. And now I need E, and E is equal to, what is the result? E is equal to V by L. The relation between electric field and potential, E is equal to V by L. Make use of these things. E is equal to I. R means rho L by A. Rho L by A, resistance of a wire, and the denominator term is L, right? L gets cancelled. This is nothing but I by A times rho. And this is what is one of the results in current electricity. Yesterday we have discussed that. If you remember, you can use it straight away. What is that? E is equal to rho times J. Rho for resistivity, J for current density we have told, right? So the result now is E is equal to I by A times rho. Everything is given. Again one more time. Here it is given to be millimeter square. So this is 2 into 10 raised minus 6 meter square is one important thing. L is 0.5 meter. One more important thing. Of course, rho is straight away given in O meter, the SI unit. Substitute the values and get it. Get your answer. Now, in this, we will find an important result which can be a conceptual question. What is that? Look at this expression for E. The electric field is set up inside the conductor due to a PD. It depends upon cross section and it depends upon resistivity and all resistivity, which is the nature of the conductor, conducting material, and I for current, and this is independent of length. Length factor has been missing here. Therefore, that intensity term inside the conductor that constitutes current is independent of length. 50 centimeter is said, 50 centimeter for this dimension. If length is doubled, what happens to the intensity? It remains the same, like that. Every answer, whenever you get an answer, that answer will speak something about a concept. Find such things. For every one answer that is solved, it will be equivalent to 4 to 5 answers or 4 to 5 questions. One concept, 3 examples I am showing. Now here, one example to begin with, the simplest one is given data for 2 wires, P and Q, 2 copper wires with length and radius. The question is, arrange P, Q, R in the correct descending order of resistance. Remember, resistance Y or a conductor with given dimensions, R is rho L by pi R square. I am writing rho for resistivity. Since PQ are all made up of same material, this is a constant. So what is our principle? R proportional to L by small r square, R for radius. Now since data is given, for this data I am writing the third column. This is our solution. What is the L by R square term? This is 1 by R 0.5 means 1 by 2. 1 by 2 squared means 1 by 4. Right? Don't get confused. 1 by, 0.5 square means 0.25 can write. So this is nothing but 4. For Q, what is L by R square? L, R square is 1 square, therefore this is 2. I am simply taking the ratios. I am not taking any numerical values for further substitution. Therefore, millimeter, meter, all are, don't think that I have to convert them because it is a comparison ratio. And then here, L is 1 by 2, R is also 1 by 2 square means 1 by 4. This will give you 8. No, this will give you also 2. Therefore, I will write it as 1 millimeter. Therefore, this will be 1 by 2 by 1. This is 1. So now, R proportional to L by R square. Look at these L by R square values. 4, 2, 1 we got. Since R proportional to L by R square, now we want to descending order, which is the one with highest resistance. This one. P with highest resistance, followed by Q, and then followed by R. Like this. In this example, even an inequality can be given where 2 resistors or 2 wires can have same resistance also. In such case, we will write equality. Otherwise, now the ratio will write P greater than Q greater than R. Anywhere equality you get, you will write equality also. Options can be given like that. So the rule for given wires R proportional to L by R square. For the same rule, look at the question number 2. I said again P and Q, 2 wires. P and Q, 2 wires with the dimensions again Length and radius are given. The question is, for series combination of P and Q across 20 volts, find PD across thinner wire. Data says P 1 meter, Q 2 meter. Therefore, this is shorter wire, longer wire, thinner wire, thicker wire. Right? Length for short and long, thickness for thin and thick. No confusion. Right? Now I have to find series combination. Looks it's another question, but the same R proportional. Because in series combination we know that V proportional to R. Potential divides and potential division. The rule is always V proportional to R. And R proportional to L by R square. Therefore V1 across P and V2 across Q is L1 by L2, and this is R2 by R1 whole square. Substitution will give you 1 by 2, and R2 is 1 upon 1 by 2, therefore it is 1. V1 by V2, I got it as 1. It can be either 1 or it can be any other number. Remember, this is 1:1. Therefore, this 20 volts is to be divided. This 20 volts divided for P and divided for Q. Since the ratio is 1, it will be 10 volts and 10 volts. Or whatever any other ratio that comes, you will divide the potential according to that ratio. Got the point? Rule is R proportional to L square. Supposing, example number 3 I will show you. He says same data P and Q with the dimensions, and now the question is in a parallel combination of P and Q, across some source. He says current through longer wire is 1 ampere. Find current through short wire. Earlier it was series combination and we had divided potential. Now this time it is parallel combination, division of current. Right? What is the division rule? Current division is always I proportional to 1 by R. Therefore this is I1 by I2 is equal to R2 by R1. I1 by I2 is equal to R2 by R1. Supposing this time I change the number as, supposing this is 1 millimeter and this is also 1 millimeter. For that data, let us do this. I proportional 1 by R, I1 by I2 is R2 by R1. What is I1? This is for P and this one is for Q. So what is R2 by R1? This is L2 by L1, R1 by R2 whole square, because R proportional to L by R square. So this time what is L2 by L1? 2 by 1, and this is also 1. So R1 by R2 is equal to 2. So I1 by I2 is equal to 2. What does it mean? I1 by I2 is equal to I. So now here, see, we have taken P as P. For P1 it is current I1, for Q it is I2. And in the given example, what is this 1 ampere? 1 ampere is through longer. Longer means Q. So what is the given data? Given data is I2 is equal to 2 ampere or 1 ampere. I2 is equal to 1 ampere is the data. What is I2 value? So I1 is equal to, right, R2 by R1 times I2, that is equal to 2 ampere. Okay? V proportional to R combined with R proportional to 1 by L square. Similarly, I proportional to 1 by R combined with R proportional to 1 by L by R square. Let us come to another concept. Same resistance of a conductor. Another concept we will discuss now. Concept of resistance and variation with the size of the conductor. So one more example like this. Here, a wire is stretched such that the strain in the wire is 2. keywords stretched and strained wire is to find the percentage change in its resistance. Now, when a wire is stretched, length increases, cross section decreases, but volume remains the same. So in this case, the data says volume remaining constant. Therefore, we cannot use earlier expressions like R proportional to L or R proportional to 1 by R square, the radius of the wire. We cannot use that one. Therefore, now what we'll use? You remember, this is the expression R is rho L by A, written as, you remember, rho L squared D or rho L squared upon V for volume. This was the expression earlier we got. Have notebooks, go through one more time. Therefore, for given volume, then we have told R proportional to L squared is the result for given volume. Though when the wire is stretched, we can never use R proportional to L or R proportional to 1 by R square. The results will change. The first result in terms of length is R proportional to L square. What does it mean? R2 is L2 by L1 square times R1. Now the data says strain. Therefore, how to substitute? Yes, if I take L1 is equal to L. What do we mean by strain? Strain is delta L by L. The change in the length by initial length is what is strain. So now delta L by L given to be 2. So what does it mean? Delta L is equal to 2L. Remember, delta L is equal to 2L does not mean the length is doubled. In fact, the length is tripled. Because initial length is L, delta L is 2L. Therefore, the final length is L plus 2L is 3L. So whenever strain is given 50%, 60%, 10%, or strain is 3, strain is 4, then what is that? We have to do L plus that strain, whatever given, we will add. Therefore, here in this case, strain is 2. So, for L plus 2L is the answer. If I say the strain is 0.2, then what is the L2 value? If L1 is equal to L, L2 is L plus 0.2L. So, that is how we write the final length. So, this is L. Now, L2 is 3L squared times R1. So, this is 9 times. When there is a strain of 2 due to the stretching of the wire, the resistance has become 9 times. Again, options are very important. What will be the correct answer? Resistance becomes 9 times. If it is percentage, resistance becomes 900%. Otherwise, since it has become 9 times, increased by 8 times. Becomes 9 times means, yes, increased by 8 times. Increased by 8 times means percentage is 800%. 800%. So what is the percentage of change in the resistance? It is 800%. How we got this 800 from this 9R1? Becomes 9 times means increased by 8 times. So that the fraction multiplied with 100 will give the percentage. Got it? So when we are using R proportional to L square for a given volume, no change in volume in such case. Suppose, one more example, it is 100 ml of mercury filled in a uniform tube of radius R. Resistance of that mercury column, he says, 10 ohms. Now, the same quantity of mercury, if filled in a tube, again uniform tube of radius R by 2, find the resistance of that column. This time again let us use the rule. Now see, this is a column of radius R1, length L1. When radius of the tube changes, what happens? Length also changes. This is R2, this is L2, but volume remains constant. So again this data is the case of constant volume. So for constant volume, what is our result? Yes, R proportional to L square in terms of length for given volume and R proportional to 1 by R raise 4. These are the results for given volume. Given volume, capital R proportional to 1 by R power 4. You can directly write your answer because when R becomes R by 2, it is inverse and fourth power. Therefore, what is that? R2 is equal to 16 R1 you are getting. Otherwise, you can write the same like ratio. R2 by R1 is equal to, right? R1 by R2 whole is 4. You can substitute. R2 is equal to 16 R1. 16 R1. Therefore, this is 16 times 10, 160 ohms. You get the answer. Hope clear. We have to understand whether volume is given or masses are given, lengths and radius are given like that. Now, in these two cases, I have used this R proportional to L square and R proportional to 1 by R raised 4, right? Same expression asked as a question, but now you see what is the small difference that it makes in the data and hence in the solution. Now I say, a Y is stretched. A wire is stretched and it is a uniform stretching, everything is taken for granted. A wire is stretched such that, now look at this data, radius, I will say radius of wire, yes, I will say changes. Let us confuse the student by the data wire, radius of the wire changes by 3%. Find the change in its resistance. Okay, this one. Earlier, there was change in the length and there was change in radius, but those changes were big changes. This change, I will call it as a small change. Why? Because whenever a change is given, a change greater than 10%, wire is stretched, such that radius of the wire changes by 3%. He says changes. That change we have to substitute. Find the change in its resistance. See, earlier example and this example, the difference is earlier examples the change was bigger change, and now this time it is smaller change. So when do we say the changes are smaller? Any values less than 10 like 1%, 2%, 3%, 0.5%, all those changes are smaller changes. And any change bigger than 10% considered as big change. Now for smaller changes we cannot write a ratio like this and can find the answer. There we will use one simple mathematical approximation. And this is the one I am telling you in general for this particular case. This will arise for any other unit, any other formula, small percentage change. This is a tool, you please take it. I am writing, suppose if y proportional to x rise n, a parameter y depending upon x such that it is x rise n proportionality, this n can be either positive or negative. What is meant by n being positive? Then it is directly proportional. X increase, y increase, x decrease, y decrease. If n is negative, what does it mean? Y and x are inversely related. Decrease in x will cause increase in y or vice versa. So this is very important point in this tool. N can be either positive or negative and it carries a meaning. Now for small changes I have told you the numbers you will find 1, 2, 3, 4, 0.5, these numbers. For small changes, the rule, and I call it as a tool, delta y by y percent. The percentage change in y is n times delta x by x percent. This is the rule. N times delta x by x percent is the rule. Please do remember, we'll do such examples in all the chapters. Okay. Now let us apply this. Let us use this tool for this given data. Now here we go that capital R proportional to 1 by R power 4 for the given volume, because stretching case volume remaining constant, capital R proportional to 1 by R power 4. That is, I can write small r radius rise minus 4. Since this is small change, delta r by r% is minus 4 into delta r by r%. Substitution requires a simple logic. Please don't get confused. Along with negative sign I am writing. Now here this is minus 4 times, what is the delta r by r% given? 3%. What is the change? When the wire is stretched, radius decreases. So that it is decrement. Therefore, minus is due to this index. Now, inside this bracket, I am using minus 3. Why? Anything decrease, let us write negative. Anything which is increasing, let us write as positive, so that we don't have any confusion. Or else, in the beginning I have told you, n positive means yes, x increasing, y also increasing. If n is less than 0, it will be the inverse relation I have told you. You can use that. So it should not be any confusion. And for a very, very average mindset I am writing, this minus is due to index, this resistance, this radius is decreasing, therefore this one, so this is 12%. See, resistance delta R by R%. Now you got it as, yes, final result is very, very important. Negative of negative is the right, plus. So, plus 12%, what does it mean? The resistance has increased by, resistance increased by 12%, like that. So this is for the radius I have told you. The same if it is R proportional to L square, yeah? R proportional to L square, delta R by R% is 2 times delta L by L%. Again, increase in length, increase in radius, decrease in length, decrease in radius. So R, so the radius of a, resistance of a conductor, sizes is a very, very popular topic for us. PQ, 2 copper wires, length in the ratio 3:4, resistance in the ratio 1:2. Find the ratio of masses NP by NQ. So here we have introduced the mass term and asked you to find that. Yes? Again the popular result. R is rho L by A, which we have, yes, change it as rho L squared D by small l. L squared by V, V volume times density mass, therefore D is the density term in the numerator. So rho L squared D by L. So now this will tell you that, yes, for a given material, so both are copper wires, therefore this is a constant one, and of course the density also same because of same material. Therefore now what is that R1 by R2, or else what do you observe here? R proportional to L squared by M, right? This is the result. R proportional to L squared by M. Now since we need that of masses, now what is that? M proportional to L squared by R. So that is how we got it for mass. Why I have taken mass in LHS? So whichever quantity is asked, that I will have it in LHS. So M proportional to L squared by R. Substitute the values. Mass of the wire P by mass of the wire Q is length LP by LQ, and you can see this is index 2 squared and capital R inverse ratio, right? So I will write it as RQ by RP. Substitution, answer, right? The length ratio given to be 3:4, therefore it is 9/16, and the ratio of the resistance given to be 1:2. This is what is to be very cautious about. Order is important. There it is given as P and Q, and the order is RP, resistance of P and resistance of Q. Here what is that? Order is, yes, resistance of Q by resistance of P inverse. RQ by RP, therefore it is 2 by 1. But it is not 1 by 2, it is RP by RQ is 1:2. I am writing for RQ by RP, therefore it is 2 by 1. So such caution is very important wherever you are doing ratio example. Therefore it is 9 by 8. So the masses of P and Q in the ratio of MB by MQ is 9 by 8. Instead you can ask for data like both have same mass, P is heavier, Q is lighter wire. After getting the answer, identifying right option is the smartness of a student who prepares for any competitive examination. Because same type of answers which we do in the classroom may not be given as options in the competitive examination. So once you got the answer, identify the right option is very important. So it is how we minimize our errors. I never said don't do errors. We do commit errors, but we have to minimize them with our focused practice. Just now I have told. Learning moods, learning time. The best times to be positive and to be in action. ಕಾಯಕವೇ ಕೈಲಾಸ. ಯಾರು ಮರ್ತೋಗ್ಬೇಡಿ. ತುಂಬ ದಿವಸ ಆಯಿತು ನಿಮ್ಮ ಜೊತೆ ಈ ಮಾತು ಹೇಳಿ. Do ಕಾಯಕವೇ ಕೈಲಾಸ. Be with your good learning time. Now, got this. One more example. This time, an example, a graphical analysis I am showing. Now the question says, it's a VI graph, V on x-axis and I on y-axis. Right? The calibration, we should be very careful. And he says, these are two graphs drawn for same copper wire at two different temperatures, T1 and T2. T1 and T2 temperatures, same wire, VI graph is like this. Now the question is, if T1 is equal to 300 Kelvin, find T2. Now here two aspects we shall use. One is, remember, R proportional to 1 by tan theta was the result that we have explained earlier. When voltage axis is x-axis and current axis is y-axis, R proportional to 1 by tan theta. Otherwise, voltage on y-axis, current on x-axis are proportional to tan theta. So it is R proportional to 1 by tan theta, one result. The other result is R proportional to capital T. R proportional to capital T is one more thing. Resistance versus absolute temperature, R proportional to capital T. Actually, this may not be the rule for all conductors, but it is a very, I should say, a loosely taken result. R proportional to capital T. So when you combine these two, what is that? You get T proportional to 1 by tan theta. You can directly say R proportional to T because this is for ohmic conductor, and ohmic conductor we know that higher temperature, higher resistance, and that is why R proportional to T. So capital T proportional to 1 by tan theta. Therefore now I am writing T1 by T2, the two temperatures, is tan theta 2 by tan theta 1. We have told R proportional to 1 by tan theta, where theta is angle made by the graph with the positive x-axis. One more time, the examiner has given a question to just have a small confusion. The first axis, first temperature, second temperature T2 angle is going to be 45 degrees. For T1, the angle is given 30 degrees with positive y-axis. Therefore, this should be changed. If this is 30, remember this becomes 90 minus 30, that is 60. Therefore, for T1 temperature, the angle is not 30 degrees, it is 60 degrees. What was the data given and what was that change that I have made? Please be very careful about that. Now, therefore, tan theta 2, this is T2 temperature, angle is 45 degrees. Therefore, this is tan 45 by tan 60 degrees. So it is nothing but 1 by root 3. So T2 is equal to root 3 times T1. 300, root 3 will be answer. So 1.7 into 300 you will get as 73. Yes, 510. So more than 510 Kelvin. Remember that we have used capital T for absolute temperature, and the result we got it is also in absolute temperature. Supposing if I have to give an approximate answer, I am writing it as nearly 510 Kelvin. That's root 3 I have taken only as 1.7. It will say 1.73, it will give another value. I am taking a rough value as 510 Kelvin. This 510 Kelvin can be written as, yes, 510, yeah, minus 273. So that will be in degree centigrade. I don't write the number. Please do these addition subtraction for yourself. Don't use calculators. Don't touch calculators. At least towards the peak preparation of your CET NEET, be away from your calculator. Please. Huh? So this is 570 minus 273. The answer will be in degree centigrade. And so always the number is to be followed by a unit whenever numerical examples are given. So don't just look the numerical and go for your option. Numerical along with that SI unit or CGS unit, that is to be very important. See, so this is how we have done the case of resistance versus temperature graph asked like this. Now, resistance of a conductor, generally all these examples we have taken conductor in the form of a wire, a uniform wire, that too. For our NEET and CET, we are not taking any non-uniform cross sections. Uniform cross section, and it is in the form of wire with circular cross section, like that. Now let us have a general one, a general example that is given. He says, this is a slab made up of a metal. This is a slab, solid slab, or need not be solid slab, or even it can be a hollow slab, anything like that. This is a slab with dimensions given. What is that? This 80 centimeter is this length, 3 centimeter is the thickness, and 3 centimeter is the height. Length, breadth and height, data is given. The shape is slab, which generally we consider it as a rectangular pipe, it becomes. Now the question is, the resistance across the rectangular face is capital R. Keyword, across rectangular face is R. Find that across, that means resistance across square faces is the question. Now, generally, what do we mean by length? Suppose if I consider this as a slab, our general notation is that the biggest dimension will be the length, the other two dimensions will be B and H. This is what is our regular idea, right? Longest dimension, length, the other two dimensions B and H. No, in the case of expression when you write R is equal to rho L by A. Actually, what is the true meaning of this L and A? Earlier we were talking about a wire, therefore those use it with general notation. But now specifically let us come here. L is the distance between the ends across which PD is applied. Okay, not the longest dimension. Can I repeat? Or shall I repeat? L is length between the faces across which PD is applied. And this capital A. What is capital A? Capital A is the cross section through which we find the flow of charges. So this is what is the meaning of L and A. Therefore, now when it is said that resistance across rectangular faces, then what is that? This is the figure that you get. These are the two ends. These are the two ends. Suppose if I call them as A, some small a, small b, if I call, what is this? RAB is equal to, now this becomes length is 80 centimeter and the other two dimensions, B is equal to 3 centimeter, H is equal to 3 centimeter. Remember, here we are comparing the resistance of the conductors, and that is why we need not convert these centimeters or millimeters into meters and all. That is required if we are calculating the numerical value of resistance. RAB is equal to rho, L means 80 centimeter, A. Since it is a square surface, in square face the area will be B into H. So shall I write? This is rho L by BH. Rho L by BH. Substitute the values. This is 80 rho by 9. And in the data he says this is what is R. This value is what is R. Now let us calculate across the rectangular faces. Sorry. I will write across. Here I will use square faces. And I will say here is rectangular faces. Okay. Rectangular faces. Now rectangular faces means what are the rectangular faces? No, this is one face and this one is the other face. Now this I will write it as some P and Q, the faces, the ends. That is, now you are applying a voltage source or current source across P and Q. Earlier it was across A and B. So that is what is the meaning of this data. Therefore now what is R resistance across PQ? When I am taking such case, now what is length? Length is nothing but 3 centimeter, not 80 centimeter, because it is between these rectangular faces, right? This one is one rectangular face. Yes, this is the opposite face, and this is the dimension, which is the length between them. Look at that geometry given to be 3 centimeter. Therefore, this now this time I will write it as B into rho by L into H. Since this is square face, I can write either B rho by LH, or else I can the same write it as H rho by LB also. When it is both B and H are same, becomes same. So B rho by LH, so this will be 3 rho by 80 times 3 is 240. 240. Now let us compare RPQ by RAB. What will be the number? RPQ by RAB. It is 3 rho by 240 by 80 rho by 9. This RAB is going to be, yes, capital R. The further simplification, it is your job. Don't ask me to do that. Be with your books, be with your notebooks, be with your pens without calculator and do this calculation. So this is the aspect of, again, resistance of a conductor, but not in the regular form of wire. Then how to consider length and how to consider cross section.